All right, guys, welcome to this page of the notes. Now, what you should hopefully notice is that this is the exact same polynomial that we've been working with. I didn't change anything. It's the exact same polynomial, the exact same binomial, right? I'm just continuing with that example problem we had already used, right? This one right here, where we had done the synthetic division between my polynomial and the binomial x plus 3, and we got a remainder of 0, which tells me x plus 3 is a factor of this polynomial. So let's go ahead, just let me real quick do all of that again for you. Here's what you're going to do. You would set this x plus 3 equal to 0, which means x is equal to a minus 3. You set up your synthetic division, minus 3, 2, negative 3, minus 17, 30. We do our synthetic division, 2, minus 6, minus 9, 27, 10, negative 30. I get a remainder of 0, which tells me, yes, x plus 3 is a factor. All right, and so then what we recognize, because x plus 3 is a factor, we were then able to say, okay, what that means then is my depressed polynomial, x plus 3, my binomial, and this guy are now my factors for my original polynomial. So it's 2x squared minus 9x plus 10. Right? So that's where we had gotten to so far, right, in this problem. And now what we're going to do is keep going from there. Because here's what I ask you to do. First, determine whether x plus 3 is a factor of the polynomial. We do the synthetic division, and if I get a remainder of 0, the answer is yes. Yes, that binomial is a factor. Then I ask you to find the remaining factors of the polynomial. So I have my factor, x plus 3, and my reduced polynomial, which I get by doing the synthetic division. Now, here's the extra little bit. Back in the last section, section 5, we learned, I believe it was seven methods for factoring to help us find the factors of a polynomial. It is time to pull those tools back out of our little toolbox and look at a way to factor this guy, right? Is there some way to factor this trinomial? And there is. This is a general trinomial where the slide and divide method is going to be the way to go. So remember the way the slide and divide method works? The way the slide and divide method works is we're going to slide this front coefficient over and multiply it by my constant. So what I get is x squared minus 9x plus 20. Well, now that my leading coefficient is a 1, what I do is I split this up into two binomials, and I just need to factor it into two binomials. So x plus 3, and then my two binomials. Well, the first little bit is easy. What two things do I multiply to get an x squared? That's the easy bit, x and x. Now the slightly trickier part, I need two numbers that multiply to 20, sum to a negative 9. Actually, that's not that difficult. It would be a minus 5 and a minus 4, right? Negative 5 and negative 4 is a positive 20. Negative 5 plus a negative 4 is a minus 9. Now, we did the slide part, but remember, the method is called slide and divide. So the last thing I need to do is divide each of those numbers by my original leading coefficient. And simplify. So x plus 3, x. Now, 5 is not evenly divisible by 2, so I just leave it for the moment, 5 halves. But 4 is evenly divisible by 2, I get x minus 2. And remember, the way that we do this is when they are not evenly divisible, when you can't reduce the fraction any, you just take that denominator and you move it out in front of the x. Make it the leading coefficient. X plus 3, 2x minus 5, and x minus 2. Now, guys, let me help you see how big a deal this is. This is epic. What you have done is you were given a polynomial. And I've asked you to find the factors, ipso facto, find the roots, the zeros of the polynomial, which is exactly what you've done. You did synthetic division to determine that, yes, this guy is a factor. You then take that factor and your reduced polynomial, which you factored even further to now get these three factors, x plus 3, 2x minus 5, and x minus 2 as the factors to that original polynomial. Again, remember what this means. If you were to multiply these guys out, use the distributive property to multiply everything together, you would get back to the original polynomial that I gave you. But here's why this is such a big deal. I will then ask you to set this guy equal to 0. You see what's coming. Now that this is factored, zero product property lets me split all of those guys up and set them each equal to 0. X is equal to a negative 3. I get 2x is equal to 5, which means x is equal to 5 halves, and x is equal to 2. 1, 2, 3. These guys are my zeros. These are the x-intercepts for the original polynomial I gave you, and remember, we can use the fundamental theorem of algebra to check. The degree of this polynomial is a third degree. The fundamental theorem of algebra says the degree of the polynomial is equal to the number of zeros. I have a third degree polynomial. I had better get 3 zeros, and that's exactly what we got. Negative 3, 5 halves, and a positive 2. And what you guys have just done is absolutely, I really hope you can kind of grasp the magnitude of what you have just done. You have used synthetic division to determine whether a binomial is a factor of a polynomial. Once we determined that yes, it was a factor, we then used our factoring methods to factor the rest of our depressed polynomial to get all the factors, the remaining factors of the polynomial, which we then can use the zero product property to split them up and find all of our x-intercepts. Guys, this is epic when it comes to algebra. This is really, really important stuff. Remember, finding zeros is a huge part of algebra, and you just found the zeros for a whopper of a polynomial. So, with this new tool, head on over to the next page of the notes. We'll try a few more of these just to make sure you're comfortable with the factor theorem, and move on from there. So, head on over to the next page of the notes, and I'll meet you guys over there.